So this is part 3 of autocorrelation. To avoid the cumbersome method of direct GLS technique, we use two-stage least square technique to estimate the parameter under non-spherical model where only autocorrelation with heteroscedasticity exists, where y is equal to x beta plus u, expected value of u is equal to 0, expected value of ut comma ut minus s equal to gamma s, expected value of ut squared is equal to gamma 0. Non-spherical model autocorrelation with homoscedasticity. So if we use two-stage least square technique, we first make the non-spherical model to a spherical model by using some transformation matrix rho. So here the cocrant orcutt transformation matrix, that is rho c, its use rho c is equal to minus rho 1, the other terms are 0, 0 minus rho 1, the other columns are 0, and in the last row first column is 0, second column value is 0, third column value is 0, and the rest of the last three column these are 0 minus rho and 1. It is n minus 1 into n cross matrix. So rho c into y, we multiply the first equation y equal to x beta plus u, it's multiply rho c, that is rho c y, it's equal to rho c into x beta plus rho c into u. So here rho c y equal to y star, rho c x equal to x star into beta plus rho c u equal to u star. New transformation model, it's a spherical model. Here y star is equal to rho c y, x star equal to rho c x, and u star equal to rho c u, and rho c transpose rho c, it's equal to rho square minus rho 0 and other, the last three column value is 0, and in the second row first column value it's minus rho, then 1 plus rho square, and in the third column of the second row value it's minus rho, and the last three column value is 0, and in the last row all the values of first value of the row it's 0, column is 0, second value of the column is 0, third value of the column is 0, and last three value of the column is 0, minus rho and 1. So it is not equal to omega inverse, that is rho c prime rho c, it's not equal to rho inverse, and the dissimilarity exists in case of the proportional term 1 by 1 minus rho square and 1 elements. If we use orcutt cocrant transformation matrix of the conversion of the non-spherical model to spherical model, the original GLS and 2SLS estimator by cocrant orcutt transformation matrix does not yield the same result, because rho c prime into rho c is not equal to omega inverse, because we have lost one information for each non-stochastics and the stochastic variable. So rho y is equal to rho x beta plus rho u, and interpretation of the new model by using cocrant orcutt transformation matrix is rho y equal to y star, it's a n minus 1 cross n matrix, and the other matrix is n cross 1 matrix. If we multiply these two matrix and get minus rho y1 plus y2 minus rho y2 plus y3, minus row y1 plus yi plus 1 minus row yn minus 1 plus yn. It's a n minus 1 cross 1 matrix. X star beta, it's equal to first the matrix is, consider this matrix. Then x, that is 1 x1 1 x2 1 up to xk1 1 x1 2 x2 2 up to xk2. In the last row, that is 1 x1n x1 x2n up to xkn. And in a matrix beta 0 beta 1 beta up to beta k, if we multiply and get this one, and u star is equal to rho c u. Rho c is this matrix, and u means u1 u2 u3 up to un. If we multiply rho c and rho c cochrane orcutt transformation matrix, and you consider as a matrix, that is u1 u2 u3 up to un, then we get minus row u1 plus u2 minus row u2 plus u3 up to minus row un minus 1 plus un. Write in the ith equation as minus row y1 plus yi plus 1 is equal to minus row plus 1 beta naught plus minus row x1i plus x1i plus 1 beta 1 plus dot 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 plus minus row xki plus 1 plus minus row ui plus 1. So Candela row k modified the Cochrane orcutt transformation matrix as adding one extra row. But we will not further proceed to the Candela, and we'll stop here for autocorrelation.